Hi everyone, welcome to another episode with the Math Newt. I'm Lee Newton and we're going to talk about perimeter, area, and volume and how some of those formulas got derived. First off, the perimeter is the measurement of the distance around an object. It's actually right in the word, rim. You can think about this as the distance a rocket has to travel around the moon, or maybe how far you have to walk around a city block. It's always one-dimensional and we're thinking length. The area, on the other hand, is the two-dimensional space of an object, of a flat two-dimensional object. We also use area when we're talking about surface area of a three-dimensional object, but it's still just the amount of space on the outside. So you can think about it as how much paper you need to wrap a present, or maybe the amount of carpeting you need for your floor. Now the volume is the three-dimensional space inside of an object. So the amount of liquid in this orange juice container, or the amount of concrete in a mixer. It's also really important to be aware of your units when you're calculating these measurements. So perimeter, it's a one-dimensional measurement, so it's going to be in a length. So you might think inches or centimeters or feet. So if I have this square right here, I'm just going to be adding the sides together and my final answer will be 20 inches. If I'm going to do area, you're thinking the space inside, so your units are always going to be squared. Feet squared, centimeters squared, inches squared. Volume, three-dimensional space, so that's going to be cubed. We're going to be dealing with meters cubed, inches cubed. It's how much space is inside of the object, so it's how many cubes will actually fit inside. So here are some formulas to be aware of when you're dealing with perimeter and area. A general rule of thumb is with the perimeter, you're just adding all the sides together. But with area, we're going to want to find the space inside, and that's generally a multiplication problem. So squares and rectangles, very straightforward, we go length times width. A triangle, we have to divide by 2 because it's half of a rectangle or half of a parallelogram. A parallelogram is just base times height, but you need to be aware of that the height is the 90-degree measurement. A trapezoid is a little bit different. We have a big base, we have a small base. We need to average those together first and then multiply by the height. And with a circle, the circumference is going to be pi times diameter, and the area is going to be pi r squared. So let's switch gears and talk about three-dimensional shapes. We're going to categorize these in two different ways. Prisms are going to be more like towers, and pyramids are going to come to a point. But if you notice, a lot of these have the same base and the same height, but one is just a tower on the left and a pyramid on the right. So these three-dimensional shapes are always named by their base. So over here, if the base is a square, it is a square pyramid. Up top, bases are octagons, so I have an octagonal prism. Down on the bottom, hexagon is the base, that's a hexagonal pyramid. And over on the top left, the base kind of looks like a rectangle because that's what it's sitting on, but the base is actually a triangle because that's the shape that makes up the tower or the prism. So that is going to be a triangular prism. Here's some other three-dimensional shapes. We don't call a cylinder or a cone a circular prism or a circular pyramid. They have their own special names. But down here you can see that you can have a hexagonal pyramid and a hexagonal prism, or a pentagonal pyramid and a pentagonal prism. So the top, those are pyramids, bottom, those are prisms. So when describing a three-dimensional shape, people often use edges, vertices, and faces. Faces are the two-dimensional sides, edges are the line segments, and vertices are where the edges meet. If you think about it like marshmallows and toothpicks, the marshmallows are your vertices, the toothpicks are your edges, and the flat sides are your faces. And so in this case, we would have 6 different faces, 8 vertices, and 12 edges. So let's take a look at the volume. You might be thinking, if I have a prism and I have a pyramid with exactly the same base and exactly the same height, could their volume be related to each other? So here's a video we took in class the other day. I'm gonna start with this guy. Okay, so this is called a triangular prism. Okay, it's triangle on the bottom and it's up. It's a prism. All All right, so here's a triangular pyramid. It's always named by the base, triangular pyramid. So looking at these two, I want to see how they're related. And one of the best ways to do that is to use water, because it has to do with volume, right? It fills all the cracks in. If you're doing rice, it's not as good. Okay. I was not a bartender at any time in my life, by the way. Okay, there's one. We've got two. And we have exactly 3. So how cool is that? If you have a prism and you have a pyramid with the same base and the same height, they're just 1/3 the size of each other. So let's take a look at some formulas. Whenever you have a prism, you're going to take the area of the base times the height to find your volume. But if you have a pyramid, you're going to take the area of the base times the height, divide by 3, or multiply by 1/3. This also goes for cylinders and cones. We're going to take the area of the base, pi r squared, times the height for our cylinder, and then divide by 3 or multiply by 1/3 to get the volume of our cone. So that's all for now. Next time we're going to be talking about how to find the volume and surface area of a sphere. So stay tuned.